Good morning. Today is Tuesday, February 16th, 2021, and our I Can for today says, I can use number lines and number bonds to rename improper fractions. So real quick, let me make a couple of fractions here. Look at 3/5. Is 3/5 proper or improper? It is proper. It looks like a nice fraction. So we would put 3/5 under proper. What about 5/3? Improper. Just looks wrong, doesn't it? What about 6/4? Improper. Just looks wrong. What about 4/6? It's a proper fraction. It looks right. 2/3 is a proper fraction. And lastly, 3/2, that is improper. So what is the difference between a proper fraction and an improper fraction? We know that these fractions just look right. They look like normal fractions. And we know that improper fractions, something about them doesn't look right. Well, if I draw a picture, I'm going to pick 2/3 here. If I were to draw a picture to show 2/3 and I wanted to color it in, I would color in 2 out of 3 pictures, or pick boxes. That shows me 2/3. And if I gave you the choice, would you rather have 2/3 of a chocolate bar or would you rather have the whole chocolate bar? Well, 2/3 is smaller, so I would rather have the whole thing. Now an improper fraction, let me take 5/3 this time. Improper means it's bigger than one whole chocolate bar. So I would still split it into thirds. But if I colored in this whole chocolate bar, I would have 1, 2, 3/3. That's only 3/3, and that's not enough. I'd have to draw another chocolate bar and split it into thirds. So I have 1, 2, 3, 4, 5. I need to color in 2 more spaces. And that's how I got 5/3. 5/3 is the same as having 1 whole chocolate bar and 2/3 of another one. And this is our lesson for today. We're going to show you a couple different ways that you can take your improper fraction and change it into a mixed number. So let's start. We have 3 examples that we're going to be writing. Let's start with number 1. Our fraction is 14/5. And it just looks terrible, doesn't it? I'm going to start by drawing chocolate bars. I know it's going to be more than 1 chocolate bar, but let me just start with 1. Here's the chocolate bar. What should I split it into? Fifths. So to make fifths, I need to make 4 lines down. 1, 2, 3, 4. Then, let's see, I have 1, 2, 3, 4. That's 5/5 right there. I have the whole thing. But is 5/5 enough? No, I'm trying to come up with 14/5. Let's draw another chocolate bar. What do you think I should split this chocolate bar into? Remember, fractions like to be fair. Fifths again, good idea. So I'm going to color in all 5/5 again. That'll give me another whole chocolate bar and 5/5 and 5/5 more. That gives me 10/5. I'm getting closer. 1, 2, 3, 4, 5. This would be 6, 7, 8, 9, 10. Is that enough chocolate bars yet or not yet? Not yet. Let's draw another chocolate bar. What do you think I should split this chocolate bar into? Into fifths. 1, 2, 3, 4 lines down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14. Aha! I finally have enough pieces. So in this last chocolate bar, I have 4/5. Well, 5/5 is the same as having one whole, and 5/5 is the same as having one whole, and then I still have these 4/5 right here. That's not equal to one whole. So if I count those up, I see 1, 2, 2 wholes, and 4/5. This mixed number is equal to this improper fraction. So it was improper, and I did all of this work. It's kind of like our function machines, and I came up with a mixed number. We call it a mixed number because we have a large number and a fraction both mixed together. But this is easier to read, isn't it? We know what to picture in our minds if we're talking about 2 chocolate bars and 4/5 of another one. That's perfect. Well, there's another way that we can do this, and this is a way that some people like better. I'm going to take my 14/5 and I'm going to make a number bond for it. I want to think of all the ways I can add up to 14/5, but I'm going to start by taking out 5/5, because 5/5 is equal to one whole. So 5/5 plus 5/5, that equals 10/5. Oops, sorry. 5 plus 5, that's 10/5, plus 4/5 more. 5/5 plus 5/5 plus 4/5, that gives me a total of 14/5. Do you guys agree? Now I'm going to rename 2 of these. 5/5 is the same as one whole. 5/5 is the same as one whole. And then we still have the 4/5, because that's not the same as one whole. 1, 2, and 4/5. And this matches what we got up here. So I know that those are the same. Now there's one last way I want to demonstrate for you, and this way doesn't usually end up being anybody's favorite, but I want to show you something with it that is important, so please write this at least for this one. I want to show you how to do this on a number line. We've done lots of number lines, and you all are just about number line experts. I'm tracing the blue line from edge to edge of my paper, and I'm going to start at the red margin over here, and then I'm going to stop. Now, I know I don't usually stop there. Usually we label the other margin too, but this one's going to be a little different. I'm going to start, I know I have to label 5/5. This is 5/5 and that's 5/5. So this start's going to be 0/5. And I know I need to count up to 14/5 because that's what it says right there. So I'm going to need to make 14 more little lines. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Look, we can even put an extra line if we wanted, but you don't have to. I'm going to count in consecutive order. Consecutive means that the numbers are in order. So after 0/5, we would have 1/5, 2/5, 3/5, 4/5, 5/5. Ding, 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 ding. I know what 5/5 is equal to. Do you remember what 5/5 is equal to? Yes, that's the same as having a whole chocolate bar, but we are still counting. 6/5, 7/5, 8/5, 9/5, 10/5. Well, ding, 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 ding. I know if I have 5/5 plus 5/5, I get 10/5. This must be 2 wholes. That's how I got to 1. That's how I got to 2. 10/5, 11/5, 12/5, 13/5, 14/5, 15/5. That would give me 3. So where is 14/5 on my number line? Well, it's right here. And what do I know? This is one whole. I needed 5/5, that gave me 1 whole. 5 more fifths, that gave me 2 wholes, and then I have 4/5 more. So that shows me 14/5. Is 14/5 bigger than 1 whole chocolate bar or smaller? 14/5. It's bigger. It's a lot bigger, isn't it? It's bigger than 2 chocolate bars. It's almost 3 whole chocolate bars. All right, so let's try another one. Here's number 2. Number 2 says 13/3. You're going to take 13/3, and I want you to draw chocolate bars until you show enough pieces that show 13/3. So I'm going to start with a chocolate bar that shows thirds. 1, 2, 3. What's 3/3? How big do you think my next chocolate bar should be? Also thirds. Very good. Fractions like to be fair, so whatever we do to one, we're going to do to the rest. 1, 2, 3, 4, 5, 6. That gave me 3 more thirds. Let's try another chocolate bar. How big should this one be? Same size. 4, 5, 6, 7, 8, 9. It's another 3/3. We're not there yet, though, are we? 10, 11, 12. That's another 3/3. My goodness, we need another chocolate bar. 12, 13. And then in this last chocolate bar, I only have 1/3. So I'm going to color in the pieces that I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's count how many whole chocolate bars that is. Well, this is 1 whole. This is 1 whole. This is 1 whole. This is 1 whole. This one only has 1/3. Let's count them up. 1, 2, 3, 4, and still 1/3. So I could say this is equal to 4 and 1/3. And I know that 4 and 1/3 is equal to 13/3. And I proved it because I just drew all my chocolate bar pieces. Now there's another way to prove it, and I really like this way a little bit better. I like the number bond. So I have 13/3. I'm going to take out 3/3. So 3/3 plus 3/3. 3 plus 3 is 6/3. Let's add 3 more. That's 9/3. Plus 3 more thirds. That's 12/3. Need 1 more third. And I know if I add all of these together, 3 plus 3 plus 3 plus 3 plus 1, that would give me a total of 13/3. Let's rename some of them. So I'm going to cross off 3/3. That's 1 whole. 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 1, 2, 3, 4. Plus 1/3 more gives me 4 wholes and 1/3. And now we've double checked and proved our answer 2 different ways. Now, once you do all this work, there is a way to double check and triple check to make sure you're right. And we like to be accurate and precise, so it is worth the triple check. That's why you need paper every time you're doing your Zern. Your notebook should be right with you, open so you can work it out. I'm going to show you how to triple check 4 and 1/3. We use what's called the recycling sign. And it makes a little circle right here. And this will check for us. Watch this. 3 times 4 is 12. Plus 1 more is 13/3. We triple checked. 1, 2, 3. We know we got this one right. All right, last problem for today. If this feels hard to you, don't worry. This is our first day doing it. Just take some practice, okay? Here's number 3. I'm going to give you a mixed number this time, 2 1/4. And I want you to be able to turn it into an improper fraction. So I'm going to start by drawing my pictures like I always do. It's said to draw 2 wholes and 1/4 of another one. Well, I can do that. 2 whole chocolate bars and 1/4 of another one. Now, if I split this one into fourths, I have to split all the other ones into fourths, right? Because fractions like to be fair. Now I'm going to color in 2 holes. And 1/4 of this one. Give me a thumbs up if you agree that is 2 1/4. 1, 2, and 1/4. I'm just going to count my pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I think this equals 9/4. Well, that's good. We think it equals 9/4, right? But we want to double check. So let's take my 9/4, which is improper, and do our number bond. How many should I take out to equal 1 whole chocolate bar? 4/4 plus 4/4 plus 1/4. 4/4 is the same as 1 whole. 4/4 is the same as 1 whole. Then I still have to add that 1/4 at the end. And this gives me 2 wholes and 1/4. Is that what I started with? Yep, we double checked. Now we're going to do the triple check and we're done. We use our recycling sign. 4 times 2 is 8, plus 1 more equals 9/4. And that's what I got again. And now we have the triple check. So please take your time. Make sure you have a pencil with you when you're trying to solve these problems. And use your notebook if you get confused. Have a good day.